Good morning, good afternoon, and good evening to everyone present here. My name is Ankit Kumar, working as a consultant in DHL Supply Chain. Today, I'm going to present one of our recent projects that we have did for one of our key customers, and its name is Warehouse Simulator. So let's go to the next slide. So this is the content of my presentation. Quickly, first I will tell you about ourselves. Then we talk about objective and scope and what is opportunity all about. Then we'll quickly deep dive into a video that we have made. It will tell us what are all the process that we are covering in the simulator. Then we'll talk about the different stages that we have gone through for making this project. And then we'll see how we have validated our model against the real KPIs. And we have also prepared a scenario which is out of a slotting use case. And then we'll quickly see an application that we have developed for data preparation so that it will be easy for someone else. So just they can quickly create the data and they can use the cloud simulator. So DHL Group is consisting of 5 different verticals: DHL Express, DHL Global Forwarding and Freight, DHL E-commerce, Post and Parcel Germany. And we are part of DHL Supply Chain, specially designed for solution design. So this project is all about a customer which having more than 3 million euros AGP in warehousing, and it is an existing customer with DHL. And the whole idea about this simulator study is to create a tool which we can host in AnyLogic Cloud so that operations team can use this tool so that they can test their initiatives and strategies without any extra investment. And they can create the data on their own by transforming whatever data they have, and that can be fed to the simulator. On the right bottom side, you can see this is the complete layout, and there are only 3 key focus areas. Uh, Case reserve area, which consists of racks, and we have mezzanine as well on the middle part, you can see. And at the end, we have sorters for sortation process. So this simulator is aimed to cover all the outbound activities happening inside the warehouse. And overall area of this site is around 50,000 square meters. Talking about the products that they are keeping is footwear, apparel, and equipments. And talking about operational profile, the site currently handles around 9,000 orders per day out of 30,000 lines, and average FTEs are around 1,000. And talking about picking distribution, most of the picking is happening from the mezzanine itself. So we have modeled all the activities happening on the mezzanine in very detail. So now let's just quickly switch to the video. Then we will see what are all the process. So this video we have created using screen recording feature, and you can see this is the 3D interface of AnyLogic. Over here, you can see the 3 major areas that we have covered. On the left, we can see these are the shipment spurs for sortation. On the middle, we have mezzanine, which is G+2 levels. So these three levels are directly connected to the shipment sorter. And in the back, we have this VNA case reserve area for replenishment. So now let's just see what are the activities which are happening for picking from the mezzanine. So usually pick task from mezzanine starts with this point, which is named as Haichunka. And any picker who is going to do the picking, he will collect his task from this point only. And based on the task sequence, he will move towards different aisles for the picking process. And the pick task is designed in such a way that the travel sequence should be optimized. After the picking is done, the picker will move to the nearest VAS station. So these conveyor segments you can consider as a VAS station. Whenever the picker will pick the last item, he will get out of the aisle and he will reach to its nearest VAS segment. After reaching the VAS segment, he will scan all the cartons. We are using coordinates for tracking the nearest VAS station inside the model. So it is as accurate as possible. And after reaching the VAS station, he will scan all the cartons and identify whether any value-added services is required or not. And then he will drop all the cartons on the conveyor. There are two possibilities for the cartons. Either they could go to the end shipment sorter or to the next level. If there is a possibility of more items to be placed inside these cartons, then they will be ejected out in the next level. And after dropping all the cartons, picker will go back for the next task. So this is how task starts from the top level, and it will go to the next levels if more items to be kept on the particular carton. So this is the point that I was talking about. This is called as pick and pass point. Cartons will cartons will be ejected out of this segment, and there will be a picker who will collect all the cartons for which more items to be placed. So he will collect the number of carton based on the carton capacity. And once the capacity is reached, the system will instantly generate a new task based on the optimum task sequence, so that this process is also optimized. So for this complete warehouse, this pick and pass segment works as a consolidation element. So the whole idea about this simulator is to identify what are all the number of cartons which are going for pick and pass, because these pick and pass cartons try to increase the KPI, whether it's a wave turnaround time or it's a task turnaround time, and all the KPIs are affected by this. So that's why we have modeled this pick and pass element in same detail. So after all the cartons are collected, this picker will again go and start the picking again. So this was all about picking units from measuring, and we have also modeled full case picking, which is happening from the racks itself. So there will be an auto picker. It will pick the cartons on the pallet, and it will place it at the nearest P&D. And again, there will be another operator coming with hand pallet truck, and he will move these pallet to the nearest gas station again on the bottom level. After reaching the VAS station, he will again scan the cartons. You can see some difference in color because these green color cartons are full case and red ones are unit pick cartons. After scanning all the cartons, cartons will be dropped and they will reach to the end shipment spur based on whatever shipment ID is assigned to them. So this site consists of 32 different shorter segments, and each one belongs to a particular segment. So this is how shortation is happening. So each shorter segment has its own set of operators, but if there is a possibility of congestion in any of the spur, other operators from adjacent spurs, they will come and they will support him in terms of uh, avoiding any possibility of congestion in the main conveyor line. So this is how dynamic allocation of resources is happening inside the site and inside the model as well. So after this point, our scope ends, and this is all about all the process that are covered into the simulator. Talking about the model logic, we have modeled in the same way how these flows are distinct from each other. On the top, we have process logic for unit picking, and in the bottom flow, we are representing full case picking. And the way we have modeled each segment in a separate way so that we can update it whenever the logic needs to be updated. So we have the replenishment logic, we have picker assignment logic, we have picking logic separate for unit picking and full case picking. And we are also dynamically assigning the VAS stations, whether it's a peak season or it's an average season. And after the picking is done, we have combined these two flows because a single shorter segment is connected to these two picking. So we have then flow the flow is again combined, and we have this flow for dynamic operator assignment. This was all about the flow from AnyLogic, and we have uploaded this model into cloud so that the site team can test it on their own. And you can see this is the cloud interface. On the left-hand side, we have these multiple experiments, and this is the input section. Over here, the user just need to drag and drop the files that has to be prepared in a particular format. And user can also fix the parameters depending upon if he wants to change anything. And this is the input section. And next we have, after providing the values of the parameters and the input files, the user can just run the simulator and he can see the results within minutes. It will take around 1 or 2 minutes, run the complete simulator for the complete day. And the user can see different KPIs, whether it's the resource utilization, whether it's a congestion, and a lot. Okay, so this was all about the video. And now let's talk about what are all the process that we have gone through for making this complete model. First, we started with scope definition and data gathering. So as per data, we are using a historical transactional level data for this model, and we have transformed that data so that we can create orders for our model. And once our model was done, we have validated all the process one by one, and we have validated the KPIs that model is providing with the actual KPIs of the site. And then we have handed over this complete tool to the operations team. For this complete engagement, we have worked multiple teams inside DHL. We have written more than 1,000 lines of code in Java for AnyLogic snippets, which is for logic. And we have written some lines of code for Python as well for data preparation and data transformation. This engagement has taken more than 1,200 hours as a simulation engineer. And now let's go to the next slide. So these are the top metrics that we are evaluating for all the processes. The best and the first one is the turnaround time, because it will tell us all the detail about the complete process. Let's say, for example, it's a wave turnaround time, task, order, shipment. If there is any issue in any of these KPIs, then the user can quickly switch to the congestion metrics. He will understand what is the cause of this low turnaround time or high turnaround time. If there is a congestion, turnaround time will be high. So he can validate it using congestion. If congestion is not explainable, then the user can just quickly see the utilization, how many resources are there, whether we need more resources or not. So this is why we are focusing on these 3 KPIs. Let's say, take an example. This first graph you can focus on. This is showing the distribution of time taken by cartons on the conveyor. So user can quickly see how much time an average carton is spending on the conveyor. So with this graph, we can interpret that 80% of cartons are taking around 6.5 minutes, and 20% of cartons are taking around 10 minutes. So this is the distribution analysis. And if there is a possibility of high turnaround time for cartons on conveyor, then user can quickly switch to this congestion graph, where he will be able to see, is there any spike in any point of time over there. He can see there could be a possibility of congestion at, let's say, 12 a.m. So he can see a spike in this graph. So he can justify with this value. And similarly, again, utilization can also justify that, okay, all the spots are occupied, that's why cartons are circulating. So this is how we have connected these 3 different graphs for each of the process, whether it's a wave, whether it's a task, whether it's a picking task from Measure9, whether it's a picking task from VNRAC. So I have taken these three examples, but we have a lot in terms of dashboard because we are tracking all the KPIs. So once the model was ready, we have figured out 5 top KPIs so that we can compare the actual model, our model with the actual KPIs. So you can see the first KPI was wave turnaround time. The site was performing site was taking around 298 minutes for completing a wave on average, and our model was completing at around 286 minutes. So this KPI tells us that our model is completely accurate in terms of wave turnaround time. And the second KPI is OLP intact, but it is low for our model because it is possible that there could be some activities for this particular task which we haven't considered, so we can improve that as well. And if we can see other three KPIs, which is pallet turnaround time and task turnaround time, conveying turnaround time, these KPIs are in particular range, so we can say that our model is working very well in terms of it is showing us the reality how it is going to be. So this is how we have justified our model against the operational KPIs. So the first scenario that we have tested was a slotting one. So just to give you a flavor of what slotting is, take this baseline scenario. If you can see different colors, okay, these different colors represent different product categories which are frequently picked together, right? And it is possible that if we are receiving an order, it is possible that an order can belong to these two blue dots, which means that an average travel time of picker will be higher. But if we do the proper slotting in the warehouse, what will happen? The SKUs which are picked together will be closely placed in real, which means that average travel time of each picker will be minimized. So if you can see on the right hand side, this table where a to be scenario and as a scenario is presented, where it says that for an average aisle, it takes around an average order, it takes around 2.08 aisles to be visited. But if we do the slotting, it will be reduced to 1.78, which means the picker has to go to fewer aisles to complete an order on an average for the complete year. So this data is coming out of a simulation study, which is a uh, parallel work stream. We are using their output into our model to validate their productivities and their results. So if we can go to the next slide, we can see this is a dashboard that is we have taken snap out of the AnyLogic private cloud. So over on the left, you can see this is the input air section. And once we will run the simulator, we can compare the baseline results and our desired scenario. You can see both the scenarios are placed next to each other. That is the best part of this scenario analysis feature. You can see the wave turnaround time for the baseline was 286 minutes. But when we have incorporated the slotting results, it has reduced to 112 minutes. Similarly, all the KPIs has been improved when we are using latest slotting results. The whole reason for this improvement has been came out of because pick and pass has been reduced, which was due to the slotting exercise that we are testing. So similarly, you can see on the bottom, we have all the KPIs compared one side by side. Like you can see this turnaround time of orders, wave, delivery note, and shipment ID. So this is all about the scenario analysis that we have did. And now let's move to the application that we have developed for data creation. Okay, so we have developed this tool for the operations team, but they don't have time to prepare the data. That was the whole idea for creating this tool. So whenever someone from operations team will run this tool, they will get this interface over there. They will select few values and select some yes or no. And after that, they will be able to create different slotting scenario, different waving strategy, and they can also change the shift timings of different process as well. So by using this tool, they can create their own scenarios and they can drop it into the cloud and they can run it on their own. So this was the whole idea. And over here, you can see different snaps stacked together for the tool. So this was all about the study. And now we are in for our presentation.
Thank you so much, Ankit. We do have some questions.
So the first question is, was there any challenges creating warehouse at such a scale? So there were no such challenges. It just we have to build everything in blocks, and we have to see if there are any errors or not, and then we just build it step by step, and it is working fine. There are no issues in terms of modeling, but while running the scenarios, it will take some time if you are building a large scale model. The next second question is, what was the biggest challenge for modeling inside operation of such large facility with very long process? The biggest challenge was process understanding, and we had a lot of calls in terms of understanding the process, understanding the dependency of different process. So the 30% of time we have spent in modeling, and 70% time we have spent in understanding the process and then validation. Okay. Yeah, we have the metrics for understanding the benefits. So we have, as I have just explained, wave turnaround time, task turnaround time, and different KPIs are there. Those are warehouse specific. That's why we have included them, and we are tracking all the KPIs independently as well as into the cloud. Okay. The next question is, are there any future simulation projects in store for DHL? We are working on multiple projects. This is the first time I'm presenting in this forum, but we are working on a lot of projects in simulation in DHL.